Okay, so what this one's going to be is the sine rule. And again, we're going to go through the proof. And the way I like to do the proofs, they're all pretty much the same. Our first step, remember, we're aiming for A over sine A equals B over sine B. Our first step is to draw in the height. And that's just a perpendicular line, the height of the triangle. And that's our first step in all of them, whether we're finding the area of an area formula or the cos rule. I do it a bit different, but that's our first step. And we'll call that H just to make it nice and easy. And what we're going to do, we're going to look at the two triangles. So the first triangle we'll look at is this triangle here. And what do we know about that triangle? It's a right angled triangle, and the sine of B, the sine of this angle here, is opposite over hypotenuse. So H over A, or A sine B equals H. And that's like formula number one, if you want to call it something. And we'll come back. And now we're going to look at this triangle, the other triangle. And in this triangle, we're going to look at sine A. So we're going to look at this angle. What's the sine of A? So the sine of A equals, again, it's opposite over hypotenuse, so H over B. And so suddenly you get that H equals B sine A. And this can be formula number two. So what we've got with these two formulas is that this equals H and this equals H. So they must equal each other. And it's a nice, simple, and that's why, this proof could be very much done. It's a nice, simple, simultaneous equation now that A sine B, which equals H, must equal B sine A. And then it's just a matter of manipulating this around. If we divide both sides by sine A, what we get is A sine B over sine A equals B. And then let's divide both sides by sine B, and what we get is A over sine A equals B over sine B. So all we've done there is in this triangle, found out what sine of B is, H over A, and then manipulated a bit to get H equals A sine B. And we've done the same to get B sine A equals H. We've let them equal each other. And then here we've divided by sine A, so we've divided both sides by sine A. They've cancelled out. Then what did we do? Divide both sides by sine B. And they've cancelled out to leave what the formula is that we need to know. A over sine A equals B over sine B. If we want to look at a formula, and this is a nice, simple formula again, I think we'd be cheering if we got something like this. We're finding an angle. So I just like to flip it straight away. So instead of looking at sine A over sine A equals B over sine B, I want my unknown on the top. So I just flip this side, and if we flip this side, we have to flip the other side. So sine of theta over 14, we work in opposites, over 10 equals sine of pi on 6 over 14. Now, pi on 6 is 30 degrees. Remember, pi equals 180, so pi on 6 is going to be 30. You can change it to 30 or use radians on your calculator. And again, it's just a bit of cross multiplying. Sine theta equals sine of pi on 6 is a half. You get that straight from your calculator, times 10 divided by 14. That can be done straight on the calculator. 0.5 times 10 divided by 14 equals 0.35. That's what sine theta equals. ... How do we find the angle? We're finding an angle, so it's always shift. And I am in radians already, so that was a bit of a foolish thing to do because I'm working in degrees. Oh, what a bummer. So 0.5 times 10 divided by 14 equals 20.9 degrees. So you've just got to be very careful if you're working in degrees or radians. I was working, the calculator was in degrees. I could have worked in radians as well. A little check. This we know is 30 degrees. The smallest angle should be opposite the smallest side. So this is 10, this is 14. 14 is bigger than 10, so it's opposite a larger angle. That works for every single triangle. Basically, if it's a simple diagram, this is basically as hard as it gets. We work in opposites here, so maybe have a go at this, but because it's a bit different, but really it's a fairly standard question. We normally work in opposites. We haven't got this, but because there's two sides and two angles, we know we want the sine rule. So there's two steps there. We have to find alpha first. So sine of alpha over 21 equals the sine of 60 over 23, and do our cross multiplying again, or take this 21 up to the top. 21 sine 60 over 23. And again, it's straight on the calculator. Make sure you're in the right mode, whether it's degrees or radians. Sine of alpha equals 0.79. So shift sine. Alpha equals 52.25 degrees. So then we can find this, because angle sum of a triangle, 180 minus 60 minus the 52.25. And that would give us our answer. So 180 minus 60 minus 52.25 equals approximately 67.75 degrees. Now, obviously, we can go to bearings and that, but that's basically as hard as the sine rule gets if you've got a nice, simple diagram. Hopefully that's made a bit more sense. And again, it's a case of understanding that formula, because I think that's probably going to be what we get in the test maybe.